Well, the most important thing to keep in mind is that we utilize the scientific method when we want to try to understand how different children grow up differently in different contexts. So while individual experiences, what we might call anecdotal evidence, can be informative, in developmental science, we focus on learning from information that is collected in a systematic way that follows the 5 basic steps of the scientific method. These include beginning with some curiosity, having a particular question that you'd like to ask, and then developing an idea about what the response to that question would be. That's your hypothesis. You then set up a situation to test the hypothesis and analyze the evidence as objectively as possible, resulting in a written report or an oral report of your findings. There are really 2 different types of inquiry in developmental science, as with other kinds of behavioral science. There's quantitative research and qualitative research. In quantitative research, we're usually looking at data that is numerical, that results in scores or rankings. This is the easiest to repeat or replicate, interpret, and verify because we've done an awful lot of work on the front end, making sure that we're being as objective and numerically based as possible. So statistics become an important part of quantitative research. Qualitative research also requires that we follow very, very specific procedures to make sure we're doing it correctly. And qualitative research is not focused on numbers. It's often done in the very, very first steps of learning about a phenomena, and it is really strong in capturing the variability or the nuance in individual lives. Because in qualitative research, you're gathering narrative data, you're finding out about a person's impressions or experiences, and you're going to organize those data in an operationalized way. But you are collecting things that can't be analyzed into numbers, but can be discussed or described. Developmental science also relies a lot on survey methods, particularly when just beginning to study a phenomena or when it becomes important to try to collect a lot of data on a lot of people and try to minimize your costs and time. So surveys or questionnaires or interviews, these are quick and direct ways to obtain data from lots of people. There are, however, some measurement problems. We always have to be careful about people not necessarily always telling the truth in surveys. Or if they're talking one-on-one with an examiner, we have a higher probability of this happening in interviews. And that's just because some people might be influenced by wanting the interviewer to think highly of them. And so they may be hesitant to say some of the things that they might actually feel. So surveys can be difficult to interpret because the respondents may have some biases in how they are responding, or they may not tell the truth. There's also some research that suggests that if a person's doing an interview and the interviewer is different culturally than the interviewee, that can introduce increasing levels of bias. So it's really important to make sure that if you're using survey methods, you also incorporate other methods of the same phenomena. Now, our strongest tool in studying development is to conduct experiments. So experiments are carefully designed activities or procedures. These are manualized or operationalized so that they can be repeated by maybe the same research group or by several other research groups. In fact, because research is so difficult to conduct and because there are always alternative explanations to try to figure out, it's critical that experiments be repeated by multiple groups before we can have full confidence in our findings. When you're doing an experiment, it's important to consider that you have 2 different kinds of variables in most studies. You have an independent variable, which is the one that the scientist thinks is going to impact the outcome, and you have the dependent variable, which is the variable the scientist thinks will be affected by the independent variable. This is referred to as the dependent variable. Many times in developmental science, we will have an experimental group that receives an intervention, which can be thought of as an example of an independent variable, and we'll have a comparison group, which is comprised of individuals who are as similar as possible to the people in the experimental group, with the exception of the fact that they do not have access to the independent variable or the intervention. So let me give you an example. Say you're interested in finding out if a social skills curricula improves the friendship skills of second graders. One way to design the experiment would be to randomly assign one group of second graders to receive the social skills intervention and the other group to be a comparison, the other set of children to be in a comparison group where they are also second graders, come from the same school, but do not receive the social skills intervention. In this way, because you've done whatever you can to create these two relatively equal groups, one who gets the independent variable or the social skills intervention, our experimental group, versus the comparison group, similar on everything except no intervention. In this way, after a few months, you've delivered the intervention to one group but not to the other. You're going to come back and you're going to measure their social skills. That's the dependent variable. If the experimental group shows improvement in social skills that is above and beyond what you would expect to happen just by chance compared to the comparison group who hasn't had the intervention but has had a chance to have a few months to mature. If you find significantly better social skills in the experimental group, you might be able to conclude that the intervention has an impact on the outcome. So that is an example of how in general experiments occur. Now, as I'm sure you realize from other classes that you've taken in the social and behavioral sciences, adopting a scientific approach, doing your best to make sure you are controlling for things that could interrupt or interfere with how you're interpreting your data, all of that is quite complicated. Adding to that, we have a whole science around the methodology of research. Certain designs will enable you to have more confidence in your findings. There are other courses that you'll take at CSU that go into research design much more deeply than we will in 310. But I do want to give you a sense of how three different kinds of research can inform us in developmental science. The first design I want to mention to you is referred to as cross-sectional research. This is when you recruit different groups of people of different ages. You're recruiting them all at the same time. So in August of 2020, this researcher wanted to recruit 302-year-olds, 303-year-olds, 304-year-olds, 305-year-olds for their study on language development in males in urban Taiwan. You'll notice that the age groups are on the bottom. They are on the horizontal axis. Those are your independent variables, the age of the children. An individual child in a cross-sectional study is only in one of these groups, a 2-year-old or a 3-year-old. They are not followed up over time. These are different people in these different age cohorts. On the vertical axis, you have the average number of words spoken. So this cross-sectional study could be completed in the fall of 2020 because you're recruiting everybody at the same time, you're measuring them on the same variable, and you're looking to see if age makes a difference. Now, while that is a quick and dirty way of getting at some findings about differences between ages, it is not as informative as a more complex design, such as a longitudinal research study, which allows you to collect data repeatedly on the same individuals as they grow up. So in a longitudinal study, you would recruit a group of 2-year-olds. You would measure the number of words they say and chart those. You'd wait about 2 years. You bring those 2-year-olds back. Now you chart how many words they have. Then you bring them back again at age 6. Here in a longitudinal study, while it is more expensive, takes a lot more time, it gives you more information about the individual trajectories or growth patterns of your sample. And it is a more developmentally nuanced way of looking at the data. One of the research designs that you'll read a lot about is a combination of cross-sectional and longitudinal. This results in something we call cross-sequential research. In this study, what a researcher does is try to recruit multiple cohorts or multiple generations of children. So in 2002, they bring in their first cohort, first generation of 2-year-olds. Let's say they've got 300 2-year-olds. They measure how many words they have. Then 2 years later, they bring back those same 2-year-olds and measure how many words they have. At the same time that they bring back that first group, they also recruit a new cohort, a new generation of participants, and they measure 300 additional 2-year-olds in 2004. And the same thing happens 2 years later. By sequentially recruiting a new cohort and following up each cohort over time, a researcher is able to analyze for the differences in the age that a child started, or what we call cohort effects. What's going on in the background as these children are growing up? And could there be a difference in what a child experiences if she is 2 years old in 2002 versus if she's 2 years old in, say, 2006? Maybe there's something different in the background history that is going to impact that presentation. So a cross-sequential research design allows you to follow up several different groups over time and combines the advantages of cross-sectional and longitudinal studies. And it's a pretty powerful tool for developmental science. So when we consider which sorts of design are best, well, cross-sectional will give you the most convenient, quickest, and cheapest way to study change over time. But it doesn't tell you a lot about the processes that influence how development was changed. Longitudinal research is very useful in studying these processes over time, and it also allows us to understand the individual trajectories of growth, the individual or variable aspects of development. It takes more time and is more intensive, but you do learn more. In fact, I'll be sharing some examples from our research into longitudinal development of children with autism in future classes. And a cross-sequential approach to research, most time-consuming, most complex, but it yields the best information, and it allows you to account for potential differences in your subjects that have nothing to do with what you're actually trying to test, such as what's going on in the historical background of the cohort when you are measuring them. So another really important topic that I'd like to direct you to explore in your textbook is the idea that we have to be very, very sensitive about the ethical issues of conducting research studies with children. Children are legally thought of as a vulnerable population. In other words, we have to make sure that researchers are taking great care to protect their research subjects and make sure that they are not coercing or requiring them to do something that they wouldn't otherwise do and that could potentially be of harm. So there are several institutions that help us maintain solid research integrity. Here on campus, we have an institutional review board, or an IRB, that oversees all of the studies that are being implemented at CSU. In fact, if you are a student working in a research lab, you probably had to take a brief course in something called CITI, CITI, which is a free federal service that makes sure that anybody, student, professor, researcher in the community, is cognizant or thoughtful about the research ethical procedures that are underway. And every single research study is reviewed by a set of peers, set of other researchers, and lay people before it is allowed to be implemented. And in this way, we can make sure that as we are conducting research on development in children, that we are doing no harm, that they are participating to a degree that they've given consent to do so. And for children, you're getting the participation consent from their parents, and you're usually getting what's called assent, or an overall agreement to participate by the child. And it's very important that the ethical review board also look at the integrity of your design and make sure that you are ethically engaging people in scientific activities that have a real chance of generating knowledge. In fact, if a research study isn't designed well, that's technically not an ethical practice. So ethics and research design go hand in hand. So please take a look at your text, and in the next video, I'm going to go over an example of developmental science in action. Thank you for your attention.